And now I'm going to introduce the next presentation, which is actually the last presentation for this afternoon. I'm going to welcome Stuart Maudit, MD, SME Water, and Adam Perkins, Leakage Operations Lead, Severn Trent Water. This presentation takes a different approach to modelling, and this time focusing on dynamic pressure modelling. And we're going to provide, this team are going to provide insights into how dynamic pressure modelling analyses data from a fixed monitoring network of over 6,000 pressure flow monitoring sites across 500 DMAs and delivers a real-time response to network changes, enabling Severn Trent to quickly localise larger bursts and prioritise smaller events. It has also proven an effective alternative to fixed acoustic logging for both plastic and more rural networks. Okay, over to you, Stuart and Adam, please. Right.
Brilliant. So I'm just going to start off by talking about some of the Severn Trent programme over the last couple of years. So this started back in 2018. But before going to the technology and Stuart will go into some more of the detail, we're going to talk about some of the people journey that Severn Trent have been on over the last couple of years and how that's going to help enable the maximising some of this technology. So I'll just move on to talk about some of the Severn Trent challenges and why we changed. So just to give you a bit of background on the Severn Trent challenges, we obviously had the immediate AMP7 challenges. So just to put into context, our AMP6 challenge was around 6% leakage reduction, and we had the 15% target for AMP7. So really this was a shift in terms of the need and the size of the challenge, 60 MLD in Severn Trent terms that we were looking to save. We also, at the same time, for our PR19 plan, our water resource management plan, had some severe supply and demand deficits approaching in the next couple of AMPs. This was predominantly focused around North Staffordshire, Nottinghamshire, which by coincidence was some of our best performing leakage areas. So it just gave us that extra challenge to push leakage lower in some of our highest performing areas to achieve not only the leakage target, but also achieve some of our water scarcity challenges as well. We had about 150 MLD target across the AMP to reduce to meet some of them challenges. Now, not all of that will be through leakage, some of that's through metering as well, but we knew we had one hell of a challenge on our hands. And that for us really needed a complete shift in our strategy. So we were talking about these sort of things back in 2018. We were reviewing our operating model for people. We were testing small scale trials. But the 15% challenge really just motivated us to increase that. And our PR19 submission also needed some answers on how we were going to address some of these big challenges. So this kind of caught that perfect storm for us to look at all aspects of our leakage model. And we're just going to walk through some of our people and technology around how we've embarked and facing some of them challenges. So next slide, please. So the Severn Trent approach. So we, back in 2018 for AMP6, we had a predominantly outsourced leakage operating model where we had around 75% of our resource was externally sourced. We had a small internal resource, but they also delivered multiple measures. So they weren't solely dedicated to leakage. They were also supporting out of hours cover and supply interruption. So we didn't have an internal dedicated resource, and we had a large third-party resource delivering our leakage target. We looked to do this completely differently. We did a small-scale trial in one of our areas in Shropshire, and we looked to bring in not necessarily more people, because the model was actually we moved to was actually less people, but higher caliber, a higher skilled resource, and starting to really take that core competency back in-house. So we drove a big internal recruitment drive. We recruited 115 new roles into the business, what we called water network technicians, and we led this through an ownership and a local accountability model. So each one of our new employees would own 30 to 35, probably to 45 DMAs each, and they'd be solely accountable for the leakage in their areas. So they weren't just looking at how many leaks do I need to find this week because the model tells me to do this. It was purely looking at what needs to be true for me to reduce leakage sustainably over the long term, and how can I really understand my DMAs better than anyone else. And that helped push that ownership and accountability right to the front line of the organisation. So with these new roles, it was really clear when we went through that recruitment drive, we wanted people who were going to challenge the status quo, we're going to really adapt new technology. And, you know, this led to is kind of hiring on a behaviours and strengths model more than an experience model. We knew we had a couple of years to get ready for AMP7. And this allowed us to, so through our recruitment drive, we did bring in around 30% of our staff completely new to industry. So this is people that have never picked up a listening stick in their life. And we knew that we could train people to a certain standard over the next 18 months to get ready for them sort of challenges. We also knew that some of these people would be more kind of adventurous in terms of taking on new technology and maximizing to their full potential. And this is what we've seen. We've seen people kind of overtake some of the longer term pros quite quickly just by having that curiosity to embed some of these technologies. What also we found is that we've got an example there on the right. We create personal performance dashboards for each of our technicians. This is Luke in Leicestershire. He looks after an area you can see, and some of the lines on that top left chart is really just his historic trend lines. And you'll see the purple line, which is the last year's line where he achieved the historic best for the area. And again, up until last week, was on course for another fantastic year, other than the cold weather snap that we've seen. He's in complete control of his operability, his leakage, and also he gets to really think about how he's going to reduce leakage over the long term. So we've heard a lot about how to reduce burst for the future, and so that he's not kind of busy year after year after year, because that will kind of run its course and will run out of benefits. He needs to also think about pressure management opportunities, and to do that we need to give him some extra capacity, and that's through some of the solutions that we've looked at over the last couple of years. So just moving on to the next slide and the actual some of the kind of theory that we had at the start of the program. So we'll introduce DPM at this stage, or dynamic pressure modeling, but really it focuses on, if you look at the left-hand chart there, the traditional method of ALC or leakage detection is this kind of economic model that's built on letting leakage get up to a certain level and then it becoming kind of leaky enough to send someone in. And we kind of wanted to just bust that model completely, because we knew that that wasn't going to drive a 15% reduction over the long term and was just keeping kind of a lid on leakage, really. We knew that we had to move to a different model where we would embark into DMAs more frequently for less leakage that was available, apparently, but then bringing it down more often. So this little and often approach instead of this kind of let leakage get up to a certain point and then start to invest time and effort. And we knew that if we looked at all of our DMAs, about 3,300 of them at 7 Trent, we knew that if we managed to kind of create all of our DMAs at the lowest achieved level all at the same time, we would have dropped leakage by 150 megalitres. So we knew it was possible, but the ADOT challenge of leakage is how to keep it there. And that's where we started to look for the technology to help us do that. And that brings on to the right-hand side of the chart. So we knew that acoustic was a proven technology, and we knew that most of the industry were moving to fixed permanent acoustic loggers, and so did we. We've got a substantial amount of them, but they are perfect for certain environments. And on there, we've got a scatter graph of all our 3,300 DMAs by kind of urban to rural and metallic to non-metallic assets. We know that urban, metallic are great for acoustics, and that's where we looked to put them. But it left us a big gap in the rest of the network where we were going to have a particular problem. And that's where we looked for DPM to kind of bridge that gap. And although a less proven solution, we knew that over the long term, the more plastic assets are put in the ground, the more kind of leakage reductions that we needed in more rural areas, we needed an alternative solution, another tool in the toolkit. And that's where we looked to employ 5,000 permanent pressure loggers across 400 of our 3,500 DMAs. And so that the rough maths there is that we required about 10 to 12 permanent pressure loggers per DMA to give us this level of insight that we're going to talk about in a bit more detail. So let's move on to the next slide. So I'm just going to talk about kind of what DPM is in layman's terms and how I understand it, and Stu will go into some of the more detail. But just to give you an idea of what the frontline technicians, the water network techs see and get, and this is only a lot of work's gone into this to get to this point, probably 18 months of installation, development, fine-tuning of the algorithms to get to a point where we can start put this in into the front line. So the screenshot on the bottom left is a collector app visualization of what the guys will see now out in the field, and that will start to highlight polygons within the DMA where we believe if there's a burst, where the likelihood is that burst is appeared. So an example there's a 3Q burst in a particular area. And in this particular example, the right-hand chart shows us that it's zoned it down to a much smaller area of the DMA, reducing our time to find, but also meaning that, I guess, from an economic perspective, we want to be able to kind of do that little and often approach where we're going into DMAs, we find the leak quickly, we get back out and move on to the next one. And to do that, obviously, if we want to do that with a limited set of resources, we couldn't really, because we'd be in there surveying the whole DMA looking for one leak. We needed something that's going to help localize. And this does that for us. It also has the added benefit, we believe, is kind of reducing the need for step testing, because these are non-intrusive assets that are given as smaller zones. So in terms of narrowing down the leakage we're looking for, we're not having to spend days, night hours, and also the disruption to the network that can be caused through step testing. So it's starting to limit that as a potential of opportunity. And I guess moving on to some of the kind of early signals and early benefits that we're starting to see in our DPM DMAs, you can see there that we're starting to really get this out to most of our front end users now. So it's worth saying there's been a lot of work. We're starting to really make this kind of BAU process with the teams for them to use this day in, day out. And we can start to see that now the teams is pulling this into their day-to-day working. We're starting to see that benefit start to land in the actual frontline business. So you can see there that we are achieving around 30% faster leak find in the DPM DMAs compared to the non-DPM DMAs. So the orange line there compared to the blue line. And then moving on to the next slide, it's also helping us find leaks or number of leaks per DMA. And I know we're not in a game of just finding leaks for leaks' sakes, but it's also finding us areas of the DMAs or telling us to search for leaks in areas of the DMAs that potentially wouldn't have looked at in the past. And that's starting to see us drive leak find in them areas up. So there's some of the kind of early indications of some successful metrics coming through after a lot of hard work from Stu and the team. But now we're at this kind of tipping point where we're starting to get this into the business, starting to get the people really using this and pulling to use this on a day-to-day basis. I'm now going to hand over to Stu, who's going to talk about the kind of solution, its other aspects of the solution, what it can bring, and what we're looking to maximize over the next few years. So over to you, Stu.
Cheers, Adam. So looking at one of the advantages that we get from the pressure logging that we've got on the network is that it allows us to look at other parts, so not just the burst leakage. So Adam's talked about the burst leakage and the fast to find approach, which has been really useful. But in terms of other parts of leakage, we also accept that we've got kind of background leakage and ongoing leakage in our DMAs, but also across most of the DMAs that we've been working in, we've got large parts that just aren't leakage. So we've seen quite a few presentations today that have talked about demand anomalies in DMAs, about network configuration anomalies, boundary valves being open, and there's a real challenge there for the industry as we go through trying to hit our leakage reduction targets. Actually, there's a large proportion of our leakage, our reported leakage, which just isn't leakage at all. So if we look at how the DPM solution can impact on all three of those areas. So Adam's talked about burst leakage, and by finding these faster, being able to get the most from the resource that we've got with our localization area hotspots, we can start to reduce that. We've also in Severn Trent, some of the DMAs, we've had loggers out for 2 years, 2.5 years in some cases, and we're starting to see some real insights. So over a longer period of time, over extended data sets, you can see those smaller leaks starting to grow. You can see them develop, and particularly when you look across, say, a month's worth of data, you've got extended data sets that you can start to take out a lot of the noise and really understand what's going. So you can see things growing and then starting to go pop as bursts. Then we've got this big chunk at the bottom. So when we talk about things that aren't leakage, we've got things like network and demand anomalies that just aren't really leakage that I'm going to talk about a bit more. So these come from a number of different areas. So network anomalies, so things like open boundary valves, closed inline valves, incorrect GIS. So we saw a lot of this on the back of the 2018 hot weather incident. So there are quite a few areas where Severn Trent were forced to open up boundary valves to make sure that customers were getting the supply and the pressure that they needed. And then there was a real challenge after that period to say, well, what should the network look like? How do we know that we've put it back to how it was and our leakage reporting is accurate? So being able to compare pressures before and after gives you that accuracy and that sort of confidence that the network's doing what it should be doing. Similarly, in terms of demand anomalies, we come across a lot of, at one extreme, unknown customers. So people they're just not represented in the system. We're taking water, whether that's illegally from standpipes or otherwise. But more commonly, you've got a known customer, but actually they've got a second connection that you're just not aware of on your GIS because you've mapped what's there. You've also potentially got unlocked connections. So maybe there's two connections in there, one's metered, one's not. Or also you've potentially got meter inaccuracies happening on the network. So DPM allows us to start to understand, well, where's the flow going within our areas? Where does it matter? So as an example of this, this is one of the DMAs in Leicestershire. The analysis generated the area of interest shown there, and we had a burst that was on the continuously logged customer. So actually it was quite a large continuously logged customer, and it was downstream of the meter. What happened in this example was the team went out, did the leakage detection of that area, and came back and said, well, we can't find anything. So we got our team to check the analysis. And said, well, it's definitely in there. We need to go back in and do another sweep. And they went in and identified that it was on that customer downstream of their supply pipe, which isn't somewhere they would normally have looked. So without that confirmation and that extra kind of insight, they would have then gone on to sweep the rest of the DMA or start doing step testing, which obviously is time consuming and starts to impact on customers. So in terms of what this actually looked like on that graph there, you've got the orange, which is the DMA inlet minimum night flow. So you can see there we have a big burst that occurs on the 29th, quite substantial. The customer log data isn't recording correctly. So actually that masks that. So the leakage teams had looked and gone, well, it's not on that customer. That's one of the first things they do. And then proceeded to start looking on the network. When we gave them the confidence to go back in and they then started doing a wider sweep, they identified that the leak was there and got the logger fixed on the customer. So you can see there, that's then clearly where the problem is. The burst that gets fixed on the 26th. And you've then also got a corrected customer log data. So actually that then means the reported leakage going forward is going to be lower because that customer is properly recorded and it's been subtracted properly from the leakage data. So this slide starts to look at historical performance. So Adam's talked about the kind of the 5,000 loggers that were put out. So back sort of from summer 2019, we started working very closely with HydroSave. We've been our fieldwork partner out on this, deploying LX2 loggers from Halma. Prior to this, Severn Trent had done some extensive trials. They didn't just kind of put their finger in the air and decide they were going to throw money at this. We've done quite a lot of trials to make sure it worked and make sure the solution was going to deliver performance. So we had an area in Wolverhampton, which was about 40 DMAs, and we've since rolled out additional ones in that area. And the approach we've taken with Severn Trent is that we do entire control groups. So a control group in Severn Trent is a hydraulic area. So, for example, a group of DMAs all fed from the same pump or fed from the same tank. So here we've got a real block of the network. It's got a variety of DMAs. It's a fairly urban area, but a real kind of mixture of what's going on there. So starting from August 2019, whilst we were rolling out loggers in other areas, we started working closely with the teams to see what we could actually deliver in terms of reported leakage insight and additional information. And you can see there, we kind of had quite a big spike there in terms of lockdown fueled summer demand. But the graph is showing the monthly reported leakage in orange compared to the blue, which is the range of historical data, so 2015, 2018. So you can see before we started looking into it around August 2019, it was fairly close. And you see you really had a big separation there. So comparing historical performance of that DMA, we're seeing a 25% reduction in reported leakage. And that's a combination of different things in this area. So it's the leakage operating model that Adam's team have put in. It's the reduction in time to find. So we're finding things faster, we're getting them fixed. We haven't got things running for a long period. Also, the teams have got confidence to really go after these leaks. They go and look for something and they just can't find it. The analysis is saying, well, it's definitely there. Let's focus on this. They've got the confidence to push through. And then also we've seen some real easy wins, but some real successes in terms of identifying things that just aren't leakage and starting to really drive down those areas of performance. That's it from us. Are there any questions?
Okay, thank you, Stuart and Adam. We do have a couple of questions from Paul Parr. Adam Stewart, DPM seems an ideal solution for burst awareness. In DMAs where you have deployed DPM rather than acoustic technology,
so I can
how have you tackled reducing existing leakage
levels? So with DPM, we know that it wouldn't necessarily pick up the low-level bursts, incremental bursts. We knew that it was going to help us when we got DMAs low to keep them low. And but what Stu mentioned in the second part of the presentation was probably where we believed some of the lowest achieved levels of leakage were, this has allowed us to push on and actually challenge where we believe the true minimums are. That has helped us push some of these DMAs, not just from water leaking out of pipes, but some of the unusual demand to re-establish where the minimum is. And then I guess DPM is there as a safeguard to keep leakage low and make us aware so that we can do this little and often approach. We're not creating loads of demand for the technicians. And really, I guess there's two halves to it: how to keep it low, but also how to kind of breach new minimum historic lows. And it can do both of that. It's just that breaching the minimum historics takes probably a damn sight more effort to get there. But once you're there, the solution will make it quite easy for you to keep it there. That's the approach we're looking at.
Okay, thank you. And we have a question from Jamie Jones. Thanks, Adam Stewart. Adam, did you provide your leakage techs with additional training so that they were able to take ownership of DMAs?
If so, we did provide the guys training. So first, before we knew, because there was a lot of work to get this up and running, we wanted to do some warm-up sessions with the team to expect to give them guys an idea of what was coming down the tracks, because this wasn't an established off-the-shelf solution. So we got them really early involved in what the system's there to do, some of the methodology and the logic for why it's going to give us something different to traditional methods. And then as the solution became kind of more ready to launch, that's when Stu and the team would work more locally. So I'll pass over to Stu at this point to kind of take over from the more recent months and the embedding into the day job.
Yeah, I mean, I think it's been challenging. I think we've seen people who really wanted it and others that haven't wanted it as much, which I think you always see with these things. But as Adam said, I think the guys on the ground, they're really passionate about what they do. They've got this area and it's their patch. They're responsible for it. So they kind of, to some extent, some of them have done a really good job and they've got to as low as they really can on their own, working really hard. And they're starting to look around and say, well, how do I go to the next level? Who can help me in what we're doing? So we sort of see that draw from them and the teams. We've been working really hard really with Severn Trent to make sure that we kind of talk about digital twins and all these kind of complex analysis. I think trying to get something that the teams on the front end can understand. They can really kind of say, well, actually, here's a tool that I can pick up and use. And they don't need loads of hydraulics and loads of training and loads of kind of next level analysis to be able to make the use of. They can just pick it up and they can run with it. And yeah, the kind of the draw from the front line has been really great. And you're really starting to see that the more they use it, the more they want to use it, and the more we get great case studies and new people coming in. We've now got a wealth of case studies. So anybody who's sitting on the edge going, well, I'm not sure how this is going to help me, you can say, well, that guy over there, he's got a great case study where he didn't have to do step testing. This one, we had a case study where they dug 3 dry holes and they were still saying, well, DPM says it's definitely in this corner of the DMA. And on the 4th dig, they found it. They found the leak. So having the guys, it kind of gives them that confidence. The other thing it gives them is in the early days, we had the odd kind of phantom valve opening and things like that happening. So kind of there's activities, there's night work going on, different teams working on the network, and these guys want to know, well, who's been opening my valves? Why? Who's been messing with my network and causing problems? And the system gives them that. It gives them the ability to say, okay, well, someone opened that valve and it was at 7 o'clock on Friday night, so they can then go and march off and find out who did it, and kind of hold them to account. So yeah, there's a real drive from the teams on the front side.
Yeah, definitely.
So it helps with that sense of ownership that you talked about as well. Yeah. Okay, then I had another question from an earlier conversation. The presentation talked about the importance of Severn Trent's new leakage operating model. Do you think DPM would have worked without
number of leaks found, and that's been the kind of key driver. And that kind of blocked anyone from thinking about taking new technology, because it was like, even if it was going to help me, it was going to take some time to get used to. So we've definitely seen the leakage operating model create that draw. I think it would have been successful, no doubt, and like any other solution, it has to be successful. But when you write the business cases for these big investments, you're hoping you're going to get that extra bit of kind of fairy dust on top where people are going to take it to the next level and going to challenge these guys. So I know Stu, when we get like more complex issues, we pass that back to Stu and the team and kind of have a direct conversation with the frontline technician. We don't kind of put management in the middle. We give these guys license to call Stu and the team and say, I'm having this problem. It's not as straightforward as a first thought, and that is going to help, you know, really push SME Water as well around what can this solution give us kind of on a day-to-day basis. So we've definitely seen that. I think with anything, if you have really good people, they'll make the most of any technology. And I think we're starting to get, you know, it's worth saying that this is probably starting to become kind of company-wide product and solution for us after 18 months of real hard work. So we are in the early stages, but we're starting to see that kind of take grip in the organization now. So Stu, maybe you want to add something to that.
Yeah, I mean, I think we talked about two things there, really. The burst localization, I think as a tool, you can drop that in anywhere and it would work. It would give you some benefit. It would reduce your time to find. I mean, I showed a graph there that showed a 25% reduction in reported leakage in the areas we're working with. The reality is that takes a lot of hard work. The water network technicians in that area, we've got issues that we identified 15 months ago, which are problems with council tower blocks, lots of stakeholders involved, different parties, and the water network techs have, in some cases, it's taken a year of constant stakeholder engagement to work through those issues, to bring those stakeholders on board. You talk to council tower blocks, we've got some great cases where you've got hot water systems, you've got a central hot water tank and boiler system that's feeding 5 or 6 tower blocks across a couple of kilometres, and you speak to the councils about them and they kind of go, well, we've got another dozen of these across the whole of Wolverhampton that we weren't aware of. And those relationships have been huge. So I think without that model really pushing all the time, maintaining action registers, going and knocking on the doors every week and saying, oh, can we do this bit now? Can we get this in? Can we get this meter in? Can we dig that hole? Pushing everything through, really owning those actions and those activities. I think we would have struggled. And I think anybody who's done hydraulic modelling will appreciate that, because in the old days, you'd do hydraulic modelling, you'd have a nice report at the end that said, well, here are the problems with the model, and it'd go on a shelf and nobody ever pick it up. So the refreshing change is that in Severn Trent, you've got somebody picking it up who says, well, actually, yeah, this is my patch now. I don't want to have these anomalies in my patch. I'll bat it out the park and I'll make sure that it keeps moving until it's resolved.
Brilliant. So it's having the data and having the sense of ownership that drives the tenacity, I suppose, to seek a proper resolution. Great. Well, we have one more question here from Richard Kiernan. Are the DMAs the tech's own based on geographical location, or were they assigned to each tech so that each tech had similar levels of leakage to identify?
Yeah, so when we first started this, they are geographical patches, so they are DMAs that are close to each other and connected, because obviously, like Stu said earlier, the interrelationships between DMAs is just as important as the DMA itself if you've got open valves or different things going on in different areas. So they are geographically based, but we've tried to create, I guess, a fair system, because when we performance manage these guys, we want to make sure that they've got a fair deal each. And that is quite hard. We had to come up with quite a complex kind of matrix where we looked at kind of numbers of kilometres of main, age of material, numbers of properties, connection density. You could name so many more that we looked at in terms of burst frequency, how busy these guys going to be on a week by week basis. And there isn't a perfect science to it. So we've just gone with what we thought originally, and we have tweaked that over time. When new people have joined the business, use it as an excuse to redraw the boundaries on some areas. But we're 2 years in now, and we're really starting to see that people that have been in their patch, and a lot of the guys often live in their patch. So there's a sense of pride that they come straight out their door into their DMAs. We've seen a massive reduction in travel time. So they're on patch a lot more because they're coming out of their DMAs in their areas. And so that's that. And we know that systems and GIS can get us so far, but we really didn't underestimate the amount of local knowledge that you need from guys really understanding the nuts and bolts, especially over lockdown and stuff like that, when we were there was no history that was going to tell us what was going on during that lockdown. Getting the guys out there and actually seeing it for their own eyes, or seeing which factories were open and which weren't, these are kind of valuable tools that you just can't get into any system. So it may sound like a dark ages approach of patch ownership, but it can be brought into the future with the technology, and you're not going to get these guys holding on to their secrets and taking them to the grave with them. You won't get that. So we've seen the benefits, and it's probably worth saying that in the final year of last AMP, we delivered more than the first 4 years combined in MLD reduction. So we saw the first year of it take hold across the business, and the technology is only going to help these guys take it to lower and lower levels.
Brilliant. Well, thank you very much, Stuart and Adam. That was, again, another brilliant discussion, brilliant presentation, as have all of them been this afternoon. But that brings us to a close.